The equal exponent property says that if a raised to the power x equals b to the power x, then those two bases are equal unless x is equal to 0. We solve that by setting the bases equal to each other. So example 21, 2x plus 4 to the fifth equals 1 minus x to the fifth. We set those two bases equal to each other. So 2x plus 4 equals 1 minus x. We solve that by adding x to both sides. So 3x plus 4 equals 1. Subtract 4 from both sides, so 3x equals negative 3. Divide by 3 to get x equals negative 1. Okay, so we can do that because the exponents are equal to each other. However, if that exponent is an even number, we actually need to do something a little bit different than this. So if the exponent is even, we're actually going to set up two equations to solve. So this is example 21b. So solving the equation x plus 3 squared equals 3x plus 5 squared. The first equation that we would set up and solve is x plus 3 equals 3x plus 5. The second equation that we would set up is negative x plus 3 equals 3x plus 5. The reason we need to set up two equations is because of that even exponent. So the even exponent, whenever you have that, will set up two equations with a problem like this. The reason that we need two equations is because a positive number raised to a negative exponent is equal to that same negative number raised to the same exponent. So what I mean by that is, think about the number negative 1 squared. That answer is positive 1. And positive 1 squared is also positive 1. So that's why we have a positive option, like in equation 1 that's set up here. We'd also need to set up a negative equation to account for this other alternative, like in equation 2 here. Okay, so after you set up your first equation, which is just exactly what's there, and your second equation, which has the negative sign in front of one of the sides, then we solve by just solving the linear equation that's there. So for equation 1, we'd subtract 3x from both sides. Negative 2x plus 3 equals 5. Subtract 3 from both sides. Negative 2x equals 2. Divide by negative 2 and we get x equals negative 1 from this first equation. Second equation, we distribute this negative to start with. Negative x minus 3 equals 3x plus 5. Then to keep solving, we'd subtract 3x from both sides. We'd add 3 to both sides, get negative 4x equals 8. Divide by negative 4 to get x equals negative 2. So this equation with the even exponent, we get two answers. But if the exponent was odd, like in example 21, you get just one answer. Okay. So this two equation rule, like in 21b, that's going to apply to any even number like 2, 4, 6, 8. You're going to set up two equations in this way.